welcome to homework problems of page 6 and 7. And so for these, we're going to be doing molarity and dilution problems. So on page 6 is going to be all molarity. And so first, before you can do any of your problems, you would need to make sure that what you are given is in moles. And so if it's given in grams, you first need to convert to moles. And then next step, you can go ahead and divide your moles by the volume, which should be in liters. Okay, and so molarity uses this formula, that M is equal to the moles of your solute divided by your liters of your solution. Alright, so I'm just going to do a few problems with you. And so number 1 says, how many moles were used to make a 3 liter of a molarity of 6 calcium chlorate solution? Alright, so we are solving for moles. And so I'm going to have to rearrange this formula. And so I want to get moles by itself. And so what I'm going to do is I can multiply both sides by our liters. And so if M is equal to our moles divided by liters, the way I get liters to the other side is I just multiply it on both sides, and so liters cancel, and now I have moles is equal to our molarity times our liters. Okay, so moles is equal to 3 liters times a molarity of 6. And I'm sorry, didn't mean to write the M first. Alright, so we go ahead and just put that into our calculator. And so we have 3 times 6, and we get 18. So our answer would then be 18 moles. Okay, and then be sure you box it in so I know what your final answer is. Alright, let's move on to number 3. So number 3 says, what is volume if 2.35 moles of calcium chloride are used to make a molarity of 3 solution? Alright, so again, I'm going to have to rearrange this equation, my formula, because I want to get liters by itself. Right, so if I have M is equal to moles divided by liters, I need to get liters by itself. Right, so the way that I can do that is I can first multiply both sides by liters, and so now liters is on this side, and then I can divide both sides by my molarity. Okay, and so when I do so, molarity ends up on this side. I'm just going to rewrite this so it's more neater and so you can see exactly what the formula is. And so liters is equal to moles divided by molarity. Okay, and so now we can just go ahead and just plug in our numbers. So liters is equal to my moles, which is 2.35 moles, divided by my molarity, which is 3. Alright, so we're just going to go ahead and put this into the calculator. So 2.35 divided by 3, and we get 0.78 liters. Alright, I'm just going to go ahead and move on to number 5. So number 5, it says, what is the molarity of a solution that has a 44.3 grams of sodium fluoride in 3 liters of water? Well, notice we're given grams, and so the first thing I need to do is convert my grams into moles. Okay, so I'm going to do so by using dimensional analysis. So 44 grams of sodium fluoride, and so I need to calculate the molar mass. Alright, and so the first thing you need to do is then figure out what's the formula of sodium fluoride. Well, you would need your periodic table for this, and so sodium is Na, and fluorine is S. Okay, and then I go ahead and look at the charges. Well, sodium has a positive 1 charge, and fluorine has a negative 1 charge. Okay, so there shouldn't be any subscripts on your formula. So it's just going to be NaF. Right, so then go ahead and calculate molar mass. And so sodium has the mass of 22.990, and I'm going to add the mass of fluorine, which is 18.998. Okay, so I already put that in the calculator, and then I just hit enter. And so my molar mass of sodium fluoride is 41.988. Right, and then we just go ahead and calculate our moles. And so we have 44.3 divided by 41.988. Okay, and I get 1.06 moles. Alright, now I can go ahead and put this into my formula. So I know molarity is equal to moles divided by my liters. And so molarity is going to be 1.06 divided by 3. And I get 0.35 as my molarity. Okay, and be sure you box that in. Alright, so number 8 says what volume is used if 1.75 moles of zinc acetate are used to make a molarity of 2.1 solution. Okay, so again, I need to rearrange my formula. So molarity is equal to moles divided by our liters. And I need to get liters by itself because it's asking for volume. And so I know volume will be liters. Alright, and so that is going to be liters is equal to our moles divided by our molarity. And so go ahead and plug that in. So it's going to be 1.75 moles divided by a molarity of 2.1. Okay, so 1.75 divided by 2.1, and we get 0.83 liters as our answer. Alright, last one I'm going to do is number 9. So what is the molarity if 4.25 moles of potassium iodide is dissolved in 7.35 liters of water? Okay, so this one we are solving for M, and so we do not need to rearrange the formula. So it's just going to be molarity is equal to moles of solute divided by the liters of our solution. And so my moles is 4.25 moles divided by 7.35 liters of water. Alright, so let's go ahead and plug this in. So 4.25 divided by 7.35. And I get 0.58 as my molarity. Alright, so I'm just going to go ahead and flip the page over to page 7. Alright, so on page 7 we're going to be doing dilution problems. And so for dilution problems you're just going to follow this formula, that M1 times V1 is equal to M2 times V2. Okay, so the molarity times the volume is equal to the molarity times the volume of another substance. And so what volume of a molarity of 4.5 nitric acid stock solution is needed to make 3.5 liters of a molarity of 1.6 solution? Okay, so again I am using the formula that M1 times V1 is equal to M2 times V2. Alright, I want to know the volume of my second solution. And so I need to get volume by itself. So I'm just going to divide both sides by M2. And so when you do so, M2 cancels on one side, and you're left with V2 is equal to M1 times V1 divided by M2. Alright, so let's go ahead and plug in our numbers. And so we have 1.60 times 3.5 divided by 4.5. And so let's go ahead and put this into our calculator. So 1.60 times 3.5 and divide that by 4.5. Okay, and so I get 1.24 liters as my answer. So that would be my V2. Alright, number 3 says what volume of a molarity of 3.25 stock solution to make 4.0 liters of a molarity of 1.5 sulfuric acid solution. Okay, so again we're solving for volume. And so I'm going to use the same formula, that V2 is equal to M1 times V1 divided by M2. Okay, so let's go ahead and plug in our numbers. And so we have 1.5 times 4.0 divided by 3.25. And so I'm going to go ahead and put this into the calculator. So 1.5 times 4 divided by 3.25. And I get 1.85 liters as my answer. Right. Next one, number 5. What volume of a molarity of 4 of sodium hydroxide solution is needed to make a 2.5 liter of a molarity of 1.5 solution? Okay, again, solving for volume. And so we have V2 is equal to M1 times V1 divided by M2. Okay, so that is going to be equal to 2.5 liters times 1.5 divided by 4. So let's go ahead and put this into the calculator. Okay, and so I get 0.94 liters as my answer. Alright, number 7, 8, and 9 are more conceptual type questions, and so you just have to kind of think about it. So number 7 says you have 0.5 liters of a solution with a concentration of 1. If I evaporate off half of the solution, what happens to the concentration? Okay, so if I'm evaporating, let's just say I have Kool-Aid. Okay, so it's at a perfect concentration level. And if I was to evaporate some of the water out, but I'm still leaving the solute, so the Kool-Aid packet, how would that affect our concentration? Okay, so if you're taking away the water, you are then doubling the concentration. So your Kool-Aid is going to appear more red. Okay, so it's as if it has more of the powder in comparison to your water. And so this one, your concentration would then double. Alright, number 8, it says you have 0.5 liters of a solution with a concentration of 1. If you add water to double the volume of the solution, what happens to the concentration? Okay, again, imagine you just made Kool-Aid. It's the perfect red color. Everything tastes just right. And then you go and you add more water to it. And so instead of looking red, it looks like a pink color. Alright, so you've diluted your solution. So you've cut your concentration in half. Okay, so it's not as intense. Alright, so with that being said, I think you should be able to figure out number 9 on your own. And if you are still having trouble with any of the homework problems, be sure to stay for tutorials or to ask questions in class or see your chemistry teacher during Eagle's Nest. Alright, so until next time, enjoy doing your homework, and again, if you have questions, all you have to do is ask.